but sometimes it is also on the dangerous side, no? So we have to make adjustments if there is large difference, no, between the prediction obtained by use of the empirical equations and the actual results taken in the field. Then after that, the final step will be to do structural analysis and the design of the foundation. So this is the last step, no? So based on the soil bearing capacity, the pile load capacity, then we can design the foundation, no? So these are the 6 basic steps in the design of foundation. Now, in the next page, I have here a table showing the foundation types and the typical usage. So in the first column, I have listed here the foundation types, among which we have the spread footing, wall footing, combined footing, the mat foundation, the floating pile, the bearing pile, the drilled pier or caissons, and the retaining walls or abutments, and the sheeting structures. So as regards the spread footing, the usage is that it is used to support columns with relatively light load, but can also support heavy loads in case the soil have strong or high bearing capacity, no? So for wall footing and combined footing, so combined footing can support 2 to 4 columns or even more, no? In case the space is limited, if you, for example, consider the isolated footing and the footing areas will already overlap, then you can combine the area of you can combine the footing, no, of several columns to come up with a combined footing. So for spread wall footing and combined footing, the applicable soil condition is when the bearing capacity of the upper strata is adequate. So these types fall under the category of shallow foundation, no? Now, the mat foundation usually encompasses, no, a very large portion of the building footprint, or if not, no, in some cases the entire building footprint, no, where you have a very or single massive footing supporting all the columns, no, of the building. So that is called a mat foundation, and this is applied when the soil bearing capacity is less than that for spread footings. Then fifth, you have the floating piles, which are usually used in groups of 2 or more, and with pile cap, no? So the column is supported by the pile cap, and the pile cap are in turn supported by the piles. So floating pile and bearing pile are applied with the near surface soil is of low capacity, and for floating pile, the load transfer is by skin friction, no? As I have shown in the previous discussion, so there are 2 ways by which the pile will transmit load to the soil, no? The first mechanism is skin friction, which occurs at the lateral surface area of the pile, no? The lateral surface area by which the pile is in contact with the surrounding soil. So in the figure, it is shown here by this dash, kaning mga arrows dire, no, sa kuan. Now the second way by which the pile transmit load to the soil is by point bearing resistance at the tip of the pile. So when the soil is relatively soft, then the point bearing resistance is very low, but when the pile reaches the bedrock, then the point bearing resistance can be very high, no? So that's the difference between floating pile and the bearing pile. So floating pile is primarily transmit the load by skin friction, whereas bearing pile primarily transmit the load by point bearing resistance, no? And for larger column loads, we have the drilled pier or caissons. So same as piles, maybe floating or point bearing, or combination, no, of skin friction and point bearing reaction. Then we have the retaining wall or abutments. So this is used to retain permanent to retain material. It can be soil, no, or other granular material. So this can be used for any soil type, and the backfill, no, is made of controlled characteristic. No? So this is the example of the retaining wall. It is used where the soil cannot retain its unnatural slope. No? Then number 9, you have the sheeting structures, among which we have the sheet piles, the wood. It can be made of wood, steel, or concrete. So sheeting structures can be permanent or temporary. So temporary if used, for example, in excavation. For example, in a high-rise construction, usually there are 2 or 3 basements, no, of parking. So you have to excavate deep into the ground. No? So 3 levels of basement, that is about say 9 meters, no, of excavation plus the depth, the footing. So that will amount to about 12 meters of excavation. No? So it can to prevent lateral displacement of the surrounding soil, you know, as you excavate the soil within your within the project. You have to put or provide retaining structures. No? So commonly used are the steel sheet piles, which are driven side by side, no, in order to retain soil material. Sometimes these sheet structures are also used to retain water, no? If in case the water table is intercepted by the excavation, so we don't want water inside our excavation area, so we can do some waterproofing, no, on the perimeter of the excavation. Now next, we have here the common problems encountered in foundation. So it is important to be aware of these problems and if possible to anticipate them, no, so as not to cause delay, no, in construction, and also entail huge losses, no. So number 1 is the erosion problem. So for structures adjacent to flowing water, this is a common problem, no. Several bridges, no, their abutment eroded. So this has to be taken into consideration, especially when the foundation is close to a river, no, or a moving body of water. Okay, so the factors to determine the scour depth. So it means that the foundation has to be of sufficient embedment into the ground so that it will be below the scour depth. So usually in a river, no, when there is high velocities, the soil will be eroded. But as the velocity slows down, it will also deposit, no, the soil. So there will be a fluctuation in the riverbed. So that foundation should be below this fluctuation, no, in the riverbed. So the factors to determine scour depth are the following. So depth of prior erosion to bedrock, subsequent deposition of sediments, the stream velocity, the area runoff. Okay, possible to use a spread footing at sufficient depth, and normally piles are required to support foundation. So scour is accelerated if foundation creates channel obstruction. As in the case of a, for example, bridge structure, where you have an intermediate pier which is placed at the center of the river, no? So when you place a pier, no, at the center of the river, that will obstruct the flow and thereby increase the velocities, no, at that cross section. Then second is the corrosion problem. So for structures which are situated near old sanitary landfills, shorelines near outfall sewer and industrial plants, because the excess or the wastewater might contain some highly corrosive chemicals. Although the government regulation requires that they are not allowed, no, to discharge waste without treatment into the environment. So to address this problem of corrosion, we can use concrete resistant to corrosion. If sulfates are present, we use sulfate resistant concrete, and we can also consider the possibility of using timber piles for soil with pH greater than 9.5 or pH less than 4. Now, next we have also the water fluctuation problem. So lowered water table increases effective pressure, resulting to additional settlements. And raised water table can create instability from floating the structure and reducing effective pressure. I don't know if you have seen this in our engineering building. There were cracks which occurred in that building during the time of the long dry season. So that is during the long dry season, the water table lowered, and thereby resulting into compression or settlement of the soil, and also together with it the settlement of the foundation. So that will create a problem if the water table fluctuates, goes up and down. Then if the basement intercepts the water table, so you might need to consider waterproofing, and also you have to be very careful in doing the construction joint, because the concrete for the basement cannot be poured monolithically all at once. There has to be a construction joint somewhere. Then you have to provide proper water stops to prevent water from leaking into the basement. So this has created a lot of problems in some completed structures. So as much as possible, we have to anticipate this situation. Then fourth, you have foundation and sand deposits, so we require consideration with bearing capacity and settlement. So we know that sand is very strong when there is adequate lateral confinement, but it is weak when you remove the lateral confinement. Then you have also foundation on collapsible soils. So there are soil types which are very stiff when it is dry, but when they become wet, they tend to become also very soft. So in my practice, I've also encountered this one. So when I designed the anchor blocks for a retaining structures for a deep foundation or deep excavation rather, so I simply used the soil parameters given from the geotechnical report. So the mistake that I committed there was that when the soil is exposed due to the excavation, the properties will change when the soil becomes wet. So it resulted into tilting of the sheet piles, but it did not result into a total collapse. But there was really a problem as the sheet piles began to tilt. So we have to consider foundation on collapsible soils. Then 6, you have foundation on expansive soils. So these are the types of soils which undergo volume changes upon wetting and drying. So when they are wetted, they expand. When they dry, they contract. And if your foundation is placed on top of the soil, then there will be upward and downward movement of the foundation. And if this is not controlled, then that will result into additional stresses in the superstructure of the building. So one way to deal with expansive soil is to put a lot of weight, that is to counteract the expansion. But usually this is an expensive solution. Another efficient way will be we cannot control the expansion, but we can control the direction by which the expansion will occur. So instead of allowing the soil to expand vertically, we just allow it to expand laterally, and that is by using a waffle type foundation. Then foundation of sanitary landfills or garbage dumps. So one may undertake the following. So place additional fill to reduce pressure on the refuse zone. That is the zone containing the garbage dumps, no? So usually in a landfill, mag-excavate mo na siya, no? Then you put the garbage, then once it is full, you cover it with soil, no? And maybe after 5 years, the landfill will be sold, no? Then a new property owner will try to build a structure over the previous landfill. Then that would present some problems, no? Then 8, you have the foundation slopes. So there will be problem on soil stability against shear failure that may result in a landslide. So there are a lot of usually residential houses, no, in some of the subdivisions here in Cebu, which are situated on very steep slope. So when you do foundation design there, you have to conduct slope stability analysis, no? Because when you build a house, it will exert additional load, no, to the soil, of which it is not naturally designed to carry, no. So there might be some slippage or shear failure that will result in a landslide, especially when the soil becomes wet, no, due to constant heavy rain. Now, a structure founded on or situated in slopes, you can connect the footings together by means of the tie beams, or you consider leveling of site, but may require high retaining structures, which must be provided with adequate drainage. Okay, so just to give you an illustration, no, on some common problems we encounter in situations where we have an existing structure and you construct a new structure beside it, no. So if the existing structure, the foundation, no, of the existing structure is lower than that of the foundation of the new structure, as shown in Figure A. This is usually less of a problem, but still you have to consider, no, that when you put the new footing, it might have an influence, no, on the existing footing. It might exert an additional downward pressure on the existing footing. As you try to imagine, if you step over another person's foot, no, so that will exert a pressure. So Canada, depending on the coefficient of internal friction of the soil, so usually a 45-degree slope is assumed, no, to clear the influence, no, of the new footing to the existing footing. Now, a more serious situation will occur if the new footing is to be constructed lower than the existing footing, no? Suppose this is the new construction here and you have here the existing building. So when you excavate, that will result into loss of lateral confinement of the existing footing, no? And it will push the soil horizontally, no? And causing the soil to bulge, no, on the open excavation side, and that will result into settlement of the existing foundation. So to avoid this from occurring, no, we have to place a remedial measure, for example, a sheet pile, no, or a retaining wall to retain the soil, no, in the higher ground, shown in Figure D. Now, even if the existing and the new footings are more or less of the same level, there are also situations where the existing foundation is still manifest settlement, no, because when you excavate this portion, no, as shown in the proposed footing location. When you excavate this one, so you're actually relieving the soil, no, of its lateral confinement o sa pressure acting downward, no. So if the pressure in the existing foundation is high, so it will tend to relieve the pressure laterally, no. So that will cause bulging on the excavation side, and with the soil displaced, it will cause settlement on the existing foundation side. So there has been, in my experience, no, several disputes between new construction and existing building owner because of this behavior, no. By the way, feel free to interrupt if you have some questions, okay? I cannot see your reaction, so just feel free to interrupt, no? Now, regarding the distribution of the bearing pressure under the footing, if we have it depends on the type of soil, no, underneath the foundation. If you have a granular soil, then the distribution actually varies from maximum at the location directly underneath the column to minimum, no, at the edge of the footing. So this is the actual distribution for the granular soil as shown in figure B. Now for cohesive soil, the opposite is true, no? So you have the maximum soil bearing pressure at the edge of the footing and somewhat lower value at the center of the footing, no? That is the case for cohesive soils. Now the actual distribution is not well defined, no? So in design, we do some simplification. So instead of dealing with the non-uniform soil distribution, we just assume a uniform soil pressure distribution underneath the footing, no? So this is a simplification which will tend to overestimate if your footing is rested on granular soil, but also will underestimate, no, the requirement for shear for shear and for flexure in case the footing is situated on cohesive soil. So just be mindful of that, no? Now, the allowable soil bearing pressure is simply obtained by dividing the ultimate soil bearing pressure, which is obtained or computed using the soil bearing capacity formulas. For example, you have Tersagi's equation, no, which you have already discussed in the subject on geotechnical engineering. So you have your UU, which is the ultimate soil bearing pressure, then you divide that by a factor of safety. You will get the allowable soil bearing capacity. Now, regards the factor of safety to be used, no. Now, I have read a lot of geotechnical report, no, from geotechnical engineers. They are the consultant who prepare, no, or who interpret the result of the laboratory testing of the soil materials, no. So the geotechnical engineers are the one who recommends the allowable soil bearing capacity. So usually they recommend a factor of safety from 2.5 to 3.0, no. But again, on what exactly, no, there is no, we call this straightforward formula, no, for determining the factor of safety. So this is a judgment. It largely rests on judgment, no, on the part of the geotechnical consultant regarding the factor of safety he recommends, no. So the things that need to be considered in prescribing the factor of safety can be the number of data. So for example, the more data you gather from the field, then the more certain you are, no, regards the actual soil profile, no. But of course, with more soil data, that will entail additional cost, no. So there should be a balance, no, between the number of boreholes that you will require, no, to be conducted. So if the data is uncertain, then you have to provide a larger factor of safety. Or if the resulting data is variable, no, is too variable, then you induce a larger factor of safety into the design, no? Because no two borehole will yield exactly the same result, no? They might give you some similarity, but in some cases, they are also too different, no? So, muna siya sa factor of safety. Now, in determining the required footing area, we have here basic equations, no, from strength of materials, no. You have the bearing stress formula. So you have the bearing stress is equal to the load divided by the bearing area. If you solve for the area, then it will be the load divided by the allowable bearing stress. So we have to consider several load combinations. So we have for dead plus live, divide that by the allowable soil bearing capacity. Then for dead plus live plus wind combination, the code allows us to increase the allowable bearing capacity by 33%. No? So that is why you have there 1.33. And for dead plus live plus earthquake combination, also an increase in the allowable soil pressure is permitted, no? So 33%. So that's how we determine the required footing area. No? So that's a basic calculation in the design of foundations. Okay, so after this, let me discuss to you, no, the different modes of failure for a spread footing. Now, to be able to design a footing or foundation properly, one has to have a good understanding of the possible modes of failure, no? Because those are the failures are the ones that we want to avoid, no? So if we don't understand the modes of failure, then we cannot design it properly also, no? Because we design so as to avoid the different possible modes of failures. So in this illustration, so we have here the modes of failure for the spread footing. Now the first type is settlement, no? So by settlement, it means that there is a downward vertical movement, no, of the footing due to the soil being compressed. Okay, the soil is a compressible material, so as it is being compressed, the footing will go with it, no? So it will displace downward. Now, the cause of settlement is insufficient size. So if you have a very small footing carrying a large load, no, then it will exert a large bearing pressure on the soil. If that bearing capacity or pressure is greater than that which the soil can support, then it will result into significant amount of settlement, no? So to control settlement, either we increase the footing size or we adjust the footing depth, no? Because in some cases, the bearing capacity will improve at the lower strata, no? For example, bearing capacity at 1.5 is only 100 kilopascal, but 2 meters depth, no? The bearing capacity is already 200 kilopascal. So you might consider embedding your footing at a lower depth, no? To control sa settlement, no? Now the second type of failure, so for the first one, settlement, that is on the soil, no? Now the second type of failure is on the concrete material, no? This is called a wide beam shear failure. And if you have already undergone, no, a basic reinforced concrete design subject, then I think you already have a basic notion, no, of what a beam shear failure is, no? But in the figure, this is shown, no? So due to the upward pressure exerted by the soil on the footing, there is a possibility that the footing slab will be sheared across, no, its width. That is why it is called a wide beam, no? Wide because it cuts across the width of the footing. So the cause of wide beam shear failure is insufficient thickness. So to address this issue, we have to increase the thickness, or you can also consider increasing the concrete compressive strength, no? Now in beams, to address the shear problem, we provide stirrups, no, or shear reinforcement. But we seldom do that for footings, no? So sa footings, ang kasagaran na solution nga itong himuon, if it is insufficient regards wide beam shear, is to increase the thickness. We do not usually provide stirrups, just like in design of slabs, no? We don't provide stirrups, but we increase the thickness of the slab. Now, another type of shear failure is the punching failure. So, again, if the thickness of the footing is too thin, then the column might punch a hole through the footing, no? A hole which is geometrically similar in shape, no, to the shape of the column. So that is called a punching shear failure. Again, to address punching shear failure, we can either increase the footing thickness, which is usually the common solution, or you can increase the concrete compressive strength, no? Because the shear strength of concrete is proportionate to the compressive strength. Okay? Now, the third mode of failure for the footing is a bending or flexure failure. So the upward soil pressure will cause the footing to, of course, bend upward, no? So it is concave up. This is the deformed shape. But of course, this is greatly exaggerated, no, sa atong figure. So the cause of bending failure is, again, insufficient thickness, or that will result into crushing failure. But since footing thickness is usually governed by shear, so the thickness is usually not a problem in flexure, no? So kasagaran ang flexural failure is initiated by insufficiency of the steel reinforcement. So ang kuhanin eh, we have to provide steel reinforcement at the bottom of the footing in order to resist the tension, no? That of course at the bottom side. Okay? So kung kuha nga itong kabilya, mo na siya, mo cause siya bending failure. So mo na siya ang upat ka modes of failure for the spread footing. You have settlement, which is caused by excessive bearing stress. So to address that, we have to provide sufficient footing area, no, to reduce the intensity of the bearing pressure to a certain magnitude which can be supported by the soil, no? Then we have the wide beam shear failure. So to address this, we increase the thickness or the concrete strength. The same for punching shear failure. Then for bending or flexural failure, we can increase the number of bars, or we can increase the bar diameter, or increase the yield strength of the reinforcing bars, or we can do several of those, no? Possible nga may changes. Okay. So, next meeting, we will discuss the design of spread footing, no? I don't want to start the discussion now because we only have 15 minutes left, no? And we don't want the discussion to be cut at the middle of the solution, no, to the problem. Okay, so I think that's all for now, and my voice is also not good at this time. So, saan naman eh? Okay, so do you have any questions so far? I hope you have lots of questions. Utana lang, wala dito ibayad ni mga utana, di ba? So, any questions?
Sir, na questions, comments.
Oh, kasama diri.
Expansion of the soil can also be one of the factors in bending of the foundation daw, sir.
Kaning kang uliwa, no?
Yes, sir.
Expansion of the soil can also be one of the factors in the bending of the foundation. Actually, expansion of the soil will result into upward, vertical, and horizontal movement, no, of the foundation, depending on the direction of the expansion. No, if the soil expands vertically, then it will push the foundation up. No, if it expands sideways, no, then it will also, by friction, since there is friction between the foundation and the soil, then it will also tend to bring the foundation in the direction of its expansion. So, mauna siya nga, if the foundation is placed on expansive soil condition, one solution will be to what I have mentioned, that is put more weight, no, counteract the upward force, no, by the shear weight, no, of the foundation. Again, that is an expensive solution. So another solution will be to control the direction of the expansion by use of waffle type foundation. So the expansion is allowed to occur not in the vertical direction, which is more serious, no? It is allowed to occur laterally, no? At the within, no, the waffle portions, no. Now, I think a better solution, no, will be to do soil replacement. So you remove the expansive soil layer, then replace it with soil of better quality, no. So, ingon na kana kining usually the type of foundation which is most affected by expansive soil condition are structures which are light, no. So, for example, if you have a very tall building, then it is not really a problem because the weight of the building will usually counteract, no, any upward force exerted by the soil on the foundation. So, commonly affected are the light structures and also structures with shallow foundation, no? So, structures which are supported on piles usually are able to counteract sa mga uplift forces caused by the expansion of the soil. So, bending of the foundation, yes. If, for example, the expansion is not even, so that will cause a non-uniform movement. So it will cause bending, So I hope that answers the question. From my experience, what are the foundation failures that I have encountered? Well, let me go back to now I can show you some documents, Yes, a proof. So, someone. Wala naman ko nagka-present, Or nagka-present pa?
Present pa, sir.
Nag-present pa. Okay, let's try to look at some actual projects, Okay, let's try to open this. I hope we can get something from this. Okay. Oh, I think we have limited time, So I just show you this one here. This is the one that I mentioned a while ago. That in a high-rise condominium project, the building has, I think, 2 basements, and it is to be supported on a mat foundation. So the contractor is to excavate 8-meter depth, of excavation. So you have the top of excavation at elevation 0 and the bottom excavation at elevation -8. So to retain the soil mass here, so that it will not collapse once you excavate this part. We drive here sheet piles, Now, sheet piles can be braced or it can be unbraced, So unbraced sheet piles usually requires a longer embedment, Because it retains the soil mass by cantilever action, So mas lawom siya o kuan lubong. Yeah, usually the shear and bending moment resisted by the pile are also larger, so it will require a larger section for the sheet pile. So we have considered here 2 options. So we have the unbraced soldier pile. But although this one is costly, in terms of the pile length and the pile cross section, but it also provides you a very unobstructed space to work on, no? So mo na si advantage nini kay hawan mo kay diri, no? Now, the second option is the use of soldier or brace soldier pile. So this is our diagonal bracing, and that bracing is being it pushes against an anchor block, no? It is a reinforced concrete block. I'm not indicated here the size, no? So mauna siya. Anyway, I think this is 1.5 or 1.5 meter by 1 meter nga anchor block, no? Just to have a support for the diagonal brace. So in addition to the diagonal brace, we have also the horizontal brace to prevent the sheet pile from kicking forward, no? Now, actually, I designed this using the soil parameter indicated in the geotechnical report, which is somewhat high, no? The allowable bearing capacity at this level is around 300 kilopascals, no? That is already very good soil bearing capacity. But what we did not anticipate, no, is that when the soil layer becomes wet, no, the soil property changes, no? So, mura siya malapok, di ba? Kabantay mo na ng lapok, kauga na ang ayuta, gahi kayo, pero ikabasa sa humok sa kayo, no? If you step on it, you will even sink, no? So, muna na itabo dali, then, of course, with low bearing capacity for the anchor block, the anchor block sink, no? That cause tilting forward of the sheet piles, no? But as the anchor block is pushed downward, the soil is compressed, no? And it will exert, the more you compress the soil, the greater will be its resistance, no? You can, that is similar to, for example, if you push a spring, no? If you compress a spring, the harder you compress the further you compress the spring, the more effort you exert, no? Because the spring will provide greater resistance, no? So most ng behavior sa soil, no? There is similar ng spring behavior. So di sa ginasya mo dayon yun o kunlod, once the soil is deformed to a certain degree, no, it will also acquire sufficient bearing capacity. Okay? So wala gid siya matumbag yun, no? So unlike open excavation where there are really problems, no? For example, not on the project on which I am involved, no? But for this type of excavation, no, ang ilang gigamit is soil nailing, no? So soil nailing, ang kuhanan ng soil nail kay you drive a hole through the soil and put some rebar, then insert some concrete grout, no? Yun na. Murag yun no? Ang lansang ni mo niya. So you have there instead of a rigid nga sheet pile, you have here a softer nga barrier, no? Because you are relying now on the tension, no, in the soil nail. So na mga ingon ini nga kuan nga ni kulap yun, no? Here in Cebu, I think it was last year, at least 2 projects have this type of failure, no? Na tumpag ang iyang excavation. That's why for me, no, sheet piling is more reliable compared to soil nailing. And of course, the brace pile is more reliable compared to the cantilever pile, no? Although the bracing will create some obstruction in the working space, no? So this has to be coordinated with the structural plan, no, of the building. So I have done several design, no, for excavation protection. So that is just a sample of foundation failure. It is not a colossal failure, no. But if you can search the internet, no, you will try to search on the topic on liquefaction. So if the building is placed on liquefiable soil during earthquake, it will turn into a quicksand, no? So it does not have a bearing strength, and the building will tilt or it could topple down, no? And there are really actual cases like that, no? Ang building dili lang kay nitakilid kung tumba gyud, no? Due to loss of bearing capacity at the foundation. And of course, you have some mga landslides, no? I have investigated, no, some landslide or slope failures. Okay, I think that is what I can show for now. There's still lots to be dig into my files, no? So it is already 3 o'clock. You just reserve your questions next meeting, and hopefully my voice will improve. I have really had a difficult time talking, no? So, but I don't want to waste this meeting. I'm just staying at home. I'm not reporting to the office, no, due to this cough. Okay. So, kanila sa takot loob, no? So, thank you for attending the class. Kung pa na-publish ang files, ako i-check, ha? Naman sa kung ano,